product here. Consists of 2 parcels. There's one big box and one small slim parcel. It says Fragile. Is that Italian? This probably contains the world's smallest. Yeah, it's probably the smallest MB56 do-it-yourself kit you have ever seen. And it is called Gobel Power X files. No. Gobel Power, now it's actually called Gobel Power Project X. Let's have a look. Guys, welcome back to the Off-Grid Garage and house here in sunny hot Austria. So you pretty much like this dashboard I've shown you in the last video, so I'll show you again. We are on 55.6% state of charge, 24.1 kilowatt hours available storage at the moment. And we have an energy output of negative 150 watts. And this is because the solar system behind the pool, which is connected to the Sun GTIL inverter, but Victron doesn't see this at the moment, so that's why it shows a negative power output for the inverter. We will rectify this issue in one of the next videos, and I'll show you in all details how to integrate your Shelly devices into your Victron system so they show up as a PV inverter. And then obviously Victron knows about all your incoming solar and can calculate the power output of the inverter correctly. But at the moment we've got a negative 236 watts. And I've also added the booster function here. And this means whenever the Phoenix inverter is coming along, it says booster active. And then it also shifts this green, orange and red area of the circle accordingly. Because when both inverters are running, we've got more power available. Yeah, but more about this in a future video. Yeah, we want to have a look at this do-it-yourself box here from Gobel Power. It's called the Project X. It is on the market for quite some time, but it is very, very hidden on their website. I don't know why they hide it, because I think it's pretty cool. And they sent me this one over here probably 3, 4, 5 months ago. So it is really time to unpack everything and have a look. Alright my friends, I have now unpacked this larger box, and all this stuff, all this gear was hidden inside. So starting here from the end, we've got the frame for the battery, and you can already see the outside dimensions. It is much smaller than an MB56 battery box. Yeah, it comes with the usual PCBs for the balance cables and temperature sensors. I believe this is the lid, this is the bottom where the wheels are coming on. We've got heaps of epoxy sheets here, which I very much like. No EVA tape in between the cells, epoxy sheets, the real deal. Some more epoxy, I don't know what that is. And we even have the compatible epoxy sheets for the PCBs. Never seen this before. Usually we have EVA tape. And then we have a well organized box of screws and bolts and some, I believe these are breaker connectors. Well, we will see. Got a communication cable and 2 isolated standoffs. We've got a 100 amp 3-pole circuit breaker. This one has 10 kiloamp of breaking capacity. We have a tiny 400 amp fuse here with 20 kiloamp of breaking capacity. Ooh, we are talking about MB56 here. I'm not sure if 20 kiloamp is enough. Then we've got the usual JK Inverter BMS, which is pretty much standard now with all the boxes. Yeah, this is the brand new version 19 of the BMS with the colored balance cable connectors and also the UART port. But it is coming with an older, not touchscreen display. That is interesting. Yeah, it comes with a communication board and all the other accessories as usually. Then we've got a bag of, I believe it is M10 terminals. 1 positive, 1 negative. Massive. We've got huge and very heavy copper bus bars to connect all the cells together to a battery. And of course we've got the bus bars to connect everything together. Your battery to the BMS, to the terminals, to the circuit breaker and also to the fuse. And this is not the usual folded and flexible bus bar. this is all massive. All right, let's see what we are dealing with here. 20 millimeters by 4 millimeters. That's the same. But this one is this one is 40 millimeters by 2 millimeters. Look at this massive bus bar. Wow. Yeah, let's have a quick look. Ooh, look at this tiny fuse in here. That is pretty cool. It says West King HSF21J 400 amps, 150 volt DC, interruption current 20 kiloamps. That must be one of the tiniest T-class fuses I've ever seen. And of course, to wheel this all around, we've got 4 casters here, and they are heavy-duty, massive casters as well. Because when we built this MB56 battery box here, we are talking about around 250, 260 kilos, and this is the real deal. They're also coming with a brake. Nice. So to find this MB56 do-it-yourself kit, the Project X from Gobel Power, you have to click on these 3 lines in the top left-hand corner and go to spare parts down there. And then you scroll all the way down until you see it. And you scroll a bit further down, It gives you all the information here. This one is actually made for the 314 ampere hour cells, not for the MB56. I don't think they've got the MB56 model on their website yet. And we can download the assembly manual from the website. So there's no manual provided, no QR code. You have to find it yourself on the website. Electrical safety, battery safety, mechanical safety, general safety. Jeez. Parts list. Okay, everything is listed here with a picture next to it. So there's no confusion. Screw torque requirements. M5, M6, M8, M10. Caution, caution, caution. Okay, base assembly. There it is. I think I leave this one away here for a moment, because you and I, we have some kind of experience now with building these boxes, so let's see how we go. If we get stuck, we have a look in the manual. Otherwise, we just get started and keep going. All right. The base is ready. It is a very, very strong base. That is looking good. Okay, here comes the first misunderstanding, first issue, first problem here. So it says place base assembly. So you should ensure that the casters are securely fixed and can rotate and lock normally. So that's all good, that's what we did. Yeah, but before that, they actually assemble the cells inside these cages. So 8 cells go in the bottom cage, and 8 cells go in the top cage. Yeah, it looks like these cells are only sitting on the frame, so there's no floor where the cells are sitting on. So the cells are only sitting on these 30 millimeters on this side and another 30 millimeters on this side. But there's no support for the bottom of the cells whatsoever at all. And the manual suggests that you take these cages apart and fill one of them with 8 MB56 cells and put them on this trolley. But we have to remember this manual is actually for the MB31. So probably 8 MB31 cells is about 50 kilo-ish. So with 2 people you can still handle that. But with MB56 cells you probably won't, because this will be over 100 kilograms. Yeah, and then you've got these 2 cages on top of each other. I think we just do it like this at the moment. I just want to see how this all works, how this all looks, what the design is. And we have four screws. So while I'm mounting this cage on top of the base plate here, I just discovered some minor issues with the painting here inside this frame. There's not too much paint over there, see? So you can see the metal shining through. And there's also a bit of rust around this hole already. Now I thought this box doesn't have a compression plate, because the back side of the battery box is completely closed with this back plate, and this one is welded in. Yeah, it is welded over here, and these screws down here only holding these 2 cages together. This is actually a compression plate. When you remove these screws, this whole plate starts moving, and you use these long black screws, and it pushes this plate towards the batteries. Look at this. Bam! See, that's how far it comes out of the frame and compresses your cells. That's actually a pretty cool solution for a compression plate. And that's why you have this welded reinforcement plate. So when you tighten the screw, it actually doesn't bend the compression plate, but it pushes it towards the cells. That's a pretty cool design. So, and here at the bottom as well, the cells will only sit on the frame, not on the actual bottom. Here you can see the edge there from the frame to the base, but the cells will never touch the base. They only sit on the frame. And this is what these black insulation strips are for. So they basically go in here, one over there, one on the other side, and insulate the cage against the batteries. So these plastic strips are the only insulation they offer to isolate the cells against this metal frame. Yeah, we've got epoxy sheet here, epoxy sheet there, and in between the cells, and these plastic strips over here. There's nothing against the metal over there, and obviously there's no epoxy sheet here at the bottom because the cells are not touching the base anyway. Yeah, I'm not sure how I feel about this. Yeah, and then we've got these PCB holders with the PCBs in between. How are they? What? How does that work? They don't have any holes for screws. Nothing. They are just sitting in here. So are these epoxy sheets going in between? No, they are not. They are definitely going underneath. Somewhere like this then, when the cells are in. But these PCBs, they don't seem to have any mounting options. They're just sitting loose. Who has designed it like this? I've got a bit of silicon here at the beginning where the pins from the connector are poking through the PCB. But apart from that, everything else is completely, it is just painted or so, and then sits here on the painted metal. So I would really like to have an insulation underneath here. We've got some long holes over here, which is good attention to details, because this plate will move in, but with this long hole in place, you should find the right position for your screws. Okay, but now it gets really interesting. Because this here is the lid, the top level of your battery shelf. So it carries the PCB. It also carries the circuit breaker, the communication board, the standoff isolators, and this T-class fuse. That is the top of your battery shelf. Alright, so that is how it looks like when it's cabled. So the positive is coming from all the way from the bottom here. This is your cell number 16 here. Yeah, all the way up with this bus bar to the fuse, and from there to the outside terminal. We've got the main negative coming from the second row, coming up, going into the B negative of the BMS, and from here going into the breaker. So, breaker, I have to show you. Okay, let me show you this stuff here. This is basically a copper link which connects the breaker to the bus bar. Just let me take this one off. Yeah, and the link goes in here. Then you tighten the screw. Then you've got your M8 thread on the other side to connect to the bus bar. We've got this width on this side, and it halves on the other side where it sticks in the breaker. But the thickness does not change. So you're taking half of the material away when you go inside the breaker. I would have expected that this side is getting now double as thick to compensate for the loss in width. But no, it is not. So that's how it looks like then, yes? Alright, let's get this one out of the way and have a look what's in the other box. Yeah, they copied my battery shelf design. Big one, another big one. Ooh, that looks pretty good. I don't have that. Alright, challenge accepted. So now basically these covers go on the outside of this box. So I'm trying now for a couple of minutes to get this lid on. Well, I'm unsuccessful. Look at this gap. You can see how this side wall is bended inwards, how it curves. Front is cool, this side is cool, back is cool. And look how the links look like from the bus bar to the breaker. They stand in this direction. Same on this side, this direction, because the breaker needs to move over there to fit into this hole. But then when I tighten everything, it pulls in this side. And we clearly cannot leave it like this. So something is not quite lining up. And I think it is this bus bar, which is a bit too long. And the same for this bus bar, a bit too long. I guess that's why other manufacturers are using flexible bus bars for that. Yeah, if this bus bar would be flexible at these two bends, I can easily move it between the circuit breaker and the BMS. And this part would just compensate for a couple of millimeters. The same on this side. Make this part flexible and we don't have this issue anymore. So this is not lining up at the moment. But anyway, let's have a quick look what's going on here. So this is how the whole enclosure looks like then. It is all covered in clear PVC, acrylic. No, it's not acrylic, it's PVC. Obviously I haven't removed this protection film yet. So that's why it looks a bit bluish. All the plastic panels screw into the wheelbase. And then here at the corner, the side and front and back panels are connected with this aluminium H profile. And the lid has basically this flap on each of the sides, and this one sticks over this side panel, over the back panel, front and the other side. So it is actually pretty sturdy on the top. And I'm also a bit concerned that these parts are coming apart again, because they are not screwed or something, they are just clamped into this H profile. So and now it doesn't work anymore because the breaker needs to go like 5 mil to this side, but it can't because of the solid bus bars. So you have to move the lid and then you create this situation. Also here it is not lining up 100%. When I push it that way, it is sticking out here, the profile is visible. So this whole clear case around this box needs a bit of massaging and adjustment, so all the parts are actually fitting together. Yeah, and then I'm not sure with the cabling. So this cable here to the power switch and the display is just loose like this. And obviously with a clear case you can see it from the outside. And the same here with the communication cables. They seem to be a bit short because the one on this side goes to all the way over here and it is just enough to pull it straight underneath the BMS and it fits in. But it doesn't look good, right? The cabling doesn't look good, it looks messy, especially this one here. So there's no real instructions or a cabling guide for how to cable the communication cables, the power and display cable, and of course all the balance cables. So I guess they are running down on this side and then connect to the PCB over here and here at the bottom. But then you've got this mush of cables hanging on one side of the box. So a bit of split loom or a small conduit or a cable duct or something where the cables tuck in. Because otherwise, what's the purpose of having this clear box? And here at the back of the box, we've got 3 holes for communication cables coming in and connect to the BMS. We've got ventilation openings on this side and here on the back, over there, on the other side, but none on the front. There's no opening over here. That's fine. So I've just pulled out the 2 MB56 boxes here from Yixiang and compared this to the Gobel Power MB56 Project X, it is called. So I thought this box is a lot smaller than a usual MB56 box, but I was wrong. We're saving about 60-70 millimeters here on the length, but the Project X box is a lot higher than a usual MB56 do-it-yourself kit. Obviously you need this extra space here to have the BMS in the front, and here you need this extra space in the height to have the BMS on top. And let's shift them behind each other, and they have pretty much the same width. Yeah. Well, basically we are dealing with the same design. We've got 8 cells in series here on top of each other, and the same here in the do-it-yourself box. So there's no extra space which you could spare. Yeah, at the beginning when I opened this box and saw this cage only, I thought this is a lot smaller than the do-it-yourself kit, but it is actually not. Because we have this extra space between the clear plastic and the actual cage, we are losing quite a lot of space around this cage. So the overall footprint is actually the same, if not a bit larger. Yeah, I really thought this would be one of the smallest MB50 do-it-yourself kits you can buy, but it is not. Yeah, so overall the concept is great. I super like this idea to have this acrylic case around the battery. And as we have just seen in the video, the box has some technical and design issues which are still need to be improved. But I think a lot of these design and quality issues are related to the solid bus bars they have used. And we are just not flexible enough in this area with the circuit breaker cutout. And that's why everything is a bit bended, not matching up, overhanging. So once they possibly supply flexible bus bars, all these issues should be gone. And while we are talking about this, we have to talk about this breaker and the fuse as well. This one has an ICU of 10 kiloamps here, but the ICU is the ultimate breaking capacity. This only tells us that the breaker can disconnect 10 kiloamps without exploding. Usually the breaker needs to be replaced after that. And the ICS, this is the service breaking capacity, is only 7.5 kiloamps. So it can safely disconnect 7.5 kiloamps and can be reused afterwards. Obviously the fuse has only one parameter because when it's blown, it's gone. And I've got the MB56 battery down here. We can actually measure the internal resistance and determine the short current of this battery. Well, unfortunately, I cannot measure the MB56 battery directly here because we would need to connect to the battery terminals with the internal resistance tester. We cannot measure from the outside through the BMS. It gives you inaccurate readings or no reading at all. So this is why we are trying with this battery from Gobel Power. And this is a 280 ampere hour battery. And I basically connect directly to the positive and negative terminal of the battery. And this gives us 50.97 volts and around 5 milliohms. So if you do the maths now and divide the voltage by the internal resistance, you're getting 10.2 kiloamps. And we know from previous testing that the internal resistance of an MB56 cell is about only half of what an LF280K battery has. So we can safely assume an internal resistance of 2.5 milliohms for an MB56 battery. And to determine the maximum short current of such a battery, you also have to calculate with a maximum voltage. Battery fully charged, all cells on 3.65 volts. So the overall voltage of this battery is 58.4 volts then. So if you take the 58.4 volts divided by the internal resistance of 2.5 milliohms, you're getting a bit over 23 kiloamps for such an MB56 battery. So this would be the maximum short current, of course, for such a battery. Once this occurs and there are 20,000 amps flowing to this battery, obviously the chemistry inside such a battery is then changing. Chemicals are decomposing. A lot of heat is generated, of course. So we can safely assume the overall internal resistance goes up and therefore the short current will go down. But the first initial short current will be over 23,000 amps. So, and neither the breaker nor the fuse can safely disconnect this amount of current. And you want to use a breaker or fuse with at least 25 kiloamps of breaking capacity, if not better, 50 kiloamps. And this is why I've chosen these breakers here, because they've got 25 kiloamp of breaking capacity, 25 kiloamps, 70 kiloamps. And that's why I'm always saying, I don't think a Class T fuse is actually the solution, only if it has the correct breaking capacity. Because usually T-Class fuses can only break 20 kiloamps safely, and with the MB56, you are exceeding this. Yeah, and these ones are the right breakers, 25 kiloamp of breaking capacity, but the ICS is only 75% of the ICU, yeah, of this 25 kiloamps. So we've got only 18.7 kiloamps of breaking capacity without destroying this breaker. But of course, it is capable of disconnecting the 25 kiloamps once. Yeah, that's why I believe the breaker and the fuse need a bit of an upgrading here for the MB56. They may be okay for the MB31. So as we have just measured, we are getting a bit over 10 kiloamps of short current with such a 280 ampere hour battery. Let me have a quick look at my list here of positives and negatives again. What I've stated here is the compression plate. I really like this design with these screws and pushing the plate against the batteries and compressing them therefore. So that's a great design, I really like it. The overall quality of this box is really good, so all holes are lining up, everything is nicely made. We have these minor painting issues inside the frame. The manual online is pretty detailed and good. Also, it is missing some key elements, like for example the cable management is not mentioned at all. And this is a bit of a shame with such a case and clear plastic all around. Yeah, what I totally dislike is the PCB solution they have, that this one is just sitting loose inside this rail. There are no screws, there's no insulation to the metal. That is a really cheap and nasty design. I don't like it. What I'm also not sure about is the cells, which are sitting only on the frame, on this rail, on this side, having a thin polyethylene insulation strip underneath, no insulation to the outside of the frame. So I think they need to come up with a better solution for that. Probably a solid metal place where the cells are resting on. Yeah, everything else we have already talked about in the video. Another weird design thing is that we have the negative terminal on one side and the positive terminal on the other side. I mean, what is that for? What was the thinking behind that design? We've got the communication cables coming out of the back of the battery box. Why is there no straight connection and the connections are on the back as well? They just need to make this straight and have the connections here, so everything is on the back. But this makes no sense. And when I had a look inside the box first and saw this cage, I thought this is the smallest footprint MB56 do-it-yourself kit you can actually buy on the market. But now with the plastic around, obviously it is grown a lot bigger than expected. And when you take the dimensions and do the calculations, this Gobel Power Project X box is actually larger than a normal MB56 do-it-yourself kit. So space-wise, you're not saving anything. It is the opposite. But I guess it doesn't really matter because this box is clearly designed for people who are having only one battery or maybe two of these ones here and having them next to each other, and they are looking really great. So it is a bit of a design battery and not one of these here which you are just stacking up to get more capacity. Because with one of these here you're already getting over 35 kilowatt hours of storage. And probably two of them will do for most of the people anyway. Alright, there you have both again in one picture, the big brother, the battery shelf, and the Gobel Power Project X battery shelf on wheels. 44 kilowatt hours, 35 kilowatt hours, so not much difference. Yeah, okay my friends, I think so far this video from today, building the Gobel Power Project X battery box, so let me know in the comments down below what do you think about this. And I think it is really brave from Gobel Power to come up with such an idea, produce it, develop it, design it. It is something extraordinary, something different, something we haven't seen before. So well done Gobel Power, I really like it, even it is not perfect yet. But I think it is a great idea and I really like it. It needs some adjustments still, some improvements here and there, we have seen this. But the overall concept and design, top. And as I said, you usually only need one or two of them and you are set. Yeah, there are not too many other crazy people out there like I am. As always, I linked this box down below here. You can have a look online, get in contact with Gobel Power if you are interested. I think you need to specifically ask for the MB56 variant of it because there's only the MB31 box online in their shop at the moment. But I'll ask them for the correct link and put this all under the video. Guys, as always, thank you so much for watching. Thanks for all your amazing support here on the channel. Welcome to all the new subscribers. Welcome to all the new channel members. Thank you for your overall support and the hundreds of comments under my videos. More videos are on the way. If you like this sort of content here, give me a thumbs up. Subscribe to the channel if you haven't already. And until the next video, guys, when we do something completely different again. Until then, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye.